So yeah, welcome, and I want to thank OpenStax for hosting us this week, or this month. They sponsored the pizza too, so thanks. So, we have Stephen tonight talking about real-time dashboards, but before we get started, we're going to let Ross
A number of people were asking about, oh, these are great offices, what do you guys do, yada yada. Well, what we do is we started as a project that didn't have a name, because as you all know, names is one of the two hardest problems in software. The other two are cache coherence and off by one. We started actually in 1999. Cast your mind to back what the web was like in 1999. It did exist. There was a web. There was no Wikipedia. Google was a cute little startup that had been about 2 years old at that point. We all were using Alta Vista, if you recall. A EE professor here needed a textbook for an advanced digital signal processing course. There wasn't one textbook that he liked. There were three. They were all $200. And he did not want to make his 6 grad students who were going to take this class each shell out $600 for the one class. So he told the dean, I should just write my own textbook. And the dean told him, you don't have 3 years to waste as a junior faculty member writing a textbook, because it'll be out of date when you're done anyway. Do something clever with the web. And so he did. The clever thing he did was go talk to his grad students who then knew what to do with the web. And they said, well, maybe we can do a book the way Linux is developed, with multiple people working on it and fixing things. And the professor said, I don't want to do a multi-authored book. Those are even harder than just writing your own. He said, no, not multi-authored. Do something clever where people can just contribute and update. You just go to meetings and convince all your friends to put stuff in it. And so it started like that, and one of the key features was it had to have good math. So we were early investors in MathML. So it started with a summer project with a bunch of Rice undergrads and a few grad students. And every year started talking to funding agencies and convincing this was an interesting idea. Kind of were around at the birth of what are now called open education resources, because the idea was it would be open licenses. At the time, Creative Commons licenses didn't exist. We talked with them when they were creating the licenses. We were actually the first open commoner that they had on their page. And I was actually kind of employee number 3. I was a postdoc at Rice in a completely different field, but had a computer background from fooling around as a kid, on up for my Superboard 2, if anyone here knows about Ohio Scientific C1Ps and things like that. It was the era of the Apple II. And we've been through a couple of cycles of building things and then granting cycles shrinking us down. And now we're riding the wave of textbooks being way too expensive and not giving you enough for their value for their cost. And so we have created OpenStax College. We've rebranded OpenStax, and where we have free textbooks for everybody that we have helped edit. We paid for the content through grants with various organizations, the Bill and Melinda Gates, the Hewlett Foundation, things like that. And there are low-cost printed versions for the faculty members usually who are kind of stuck as dinosaurs. The students are more than happy to use electronic versions. That's kind of where we're at. It's very, I love the mission. I've always been an open guy. And we're continuing to hire on. So we have a couple of positions now. We actually have a Python backend position and a JavaScript frontend position. I think it's all available from openstackscollege.org. There's a tab with jobs, so you can take a look there. Any questions about what the heck we do, you can talk to me later, and we'll go ahead and have building real-time dashboards. All right, I'm excited to hear too.
Hi, I'm Stephen Cassidy. I'm a freelance software developer, and I'm going to sit down for the rest of this talk. But so basically, I think we'd all be really surprised at how much of the U.S.'s GDP runs on really old, crappy software that works, and no one's going to touch it, right? I mean, there's been a lot of articles in the past about Department of Defense looking for COBOL programmers because they're trying to overhaul the salary payment infrastructure that the military uses, and then it goes, billions of dollars over budget and never finishes. So I've kind of noticed that there's frequently a need to have older technologies provide information in a way that allows the company to sort of view it in a modern sense. Business analytics has really caught on, but getting the data is really hard. And so I've worked on a couple projects where we try to come up with crazy systems to sort of aggregate and combine things. And seen a lot of stuff not work. So this is me after watching this not work for a while. Wanted to try to solve it with newer, fancy technology. So yeah, so like I said, there's always going to be some person in the business organization that wants some Web 2.0, or Web 3.0, real-time dashboard for analytics, and they want to integrate a bunch of old stuff. No one who made it's around, and nobody in the company writes COBOL or AS400 code or whatever it may be anymore.
Just right, do we have public network here?
Rice visitor. You can use that.
And you just click a button to so yeah, so I think that's, I think a lot of us are very fortunate that we get to work with like fairly new, bleeding edge stuff, and we don't realize how bad it can be. So yeah, so one solution that it's not my idea. I read a lot about this in the last couple of years, probably by content marketing articles put forward by the companies that are using these technologies. So we'll have to take the bias with it. But the whole log-based, sort of a log-based application structure, where basically everything, here we'll say that the application could be a whole bunch of different systems talking, and so if they just create a log, and we then, by analyzing that log, generate some new utility for the organization, and then you can use, with a log-based approach, you can use it to have dashboards, do alerts. You can have it feed into and sort of populate any sort of data warehousing system that you have going on, and probably a bunch of other stuff I'm forgetting. So in this case, it's going to be similar to a talk I gave at a very quick talk I gave at PyTexas, but using only Python or some JavaScript. And let's say we have a legacy system which only tells us, like the temperature of a production machine. In this case, it was either injection molding or sort of like metal stamping machine, which are normally controlled by PLCs. And I've seen scenarios where companies are using like Raspberry Pis to gather like voltage change and use that to indicate that like that had created one unit, and that would send a message to one system, which would then be aggregated by other systems. So I picked 3 tools to try to do this with. So I used Flask, which is a Python web framework, Apache Kafka, and Apache Storm. And I'm going to go into what all those mean now, or what they are. So Flask, it's a really minimal Python web framework. If you've used Django, it's kind of like the minimalist, very different sort of philosophies to it. Way less stuff to it. I mean, if you want to write a Flask app, you basically you basically connect a function to a URL, and then like it works. So it's very good for that kind of stuff, and I like using it for APIs and smaller projects. It actually was an April Fool's joke, because at the time there was this sort of competition about who could have the most minimalist Python framework, and so the guy Armin, who eventually made Flask, like base64 encoded like a whole bunch of different libraries, and then made it one string, and then put it on the internet and said this is a one-line Python web framework. So for here, we're going to use Flask very, very simply, and all it's going to do is receive data from other legacy systems, and then power the real-time dashboard, which is going to be using server-side events. Apache Kafka, this is a distributed pub sub commit log, is how they call it. It was made by LinkedIn, written in Scala, and they use it all for all of the sort of like interactions and analytics for all of LinkedIn. So sort of like the words, the language you need to know when you talk about Kafka is message is sort of the most basic thing. So message is payload of bytes. So since it's bytes, you can do any type of data as long as you convert it. So CSVs, images, JSON, whatever, you can put it into Kafka. So Kafka has topics, which are named groupings for messages. And the nice thing about topics is you can configure them to only hold on to data for like 10 seconds or 3 months, and you can use that a whole bunch of different ways, and things are always ordered. So you can always say like this happened, then this happened, which frees up some opportunities in the future. And so in Kafka, a producer is anything that publishes a message to a topic, and a consumer is anything that takes a message from a topic. And since Kafka has clients in any language, you could write the producer in Java and the consumer in Lua, or any sort of crazy combination that you wanted. So it's very, you can make a very decoupled system that way. So in this case, potential use case or common use cases for Kafka are website activity tracking, metrics, log aggregation, stream processing, event sourcing, and commit logs. And like I said, website activity is what LinkedIn was using this for initially. So like maybe this user clicked on his profile, then clicked on his connections, then sorted by this, and maybe they inferred some insight from that. And so in this case, we're gonna, very simple usage of Kafka. I'm gonna create 4 topics. One is just raw temperatures. So every second, these theoretical fake machines that we have in our bake factory are just going to send a message of their current temperature, because that's something you want to monitor. Things get too hot, things can break or cause other problems. Then we also have one that just sends a message anytime it's produced an individual unit. And then we sort of have these 2 other Kafka topics, and they are sort of the results of processing. So one of them is, if the temperature is the same 100 times, we don't need to update the server or the client, the dashboard 100 times if the temperature never changes. We only want to send an event when the temperature changes. And then, since these are moving really fast, we don't want to be continuously sending sort of an increment command basically to the client so that it has the correct number of units produced for the dashboard. So here we're going to have Kafka feed the dashboard. So actually with the server-side events in Flask, which I'm going to show in a little bit, it's consuming off the one Kafka topic just to send messages to the dashboard. And then it also is consumed by our Storm topology. What is a Storm topology? So Apache Storm is a distributed computation framework. It was originally created at a startup that was doing like Twitter analytics. Twitter eventually bought them, mostly for this technology, and they've actually now replaced Storm with something called Heron, which is an open source shed. It's mostly in Clojure, and you do have to touch a little tiny bit of Clojure when you use Apache Storm with Python, with the libraries that are available. And so you get the sort of language you need to know to talk about Storm. So there's a tuple, and if you're a Python guy, don't get too confused with a tuple in Python, because they do have named. So it's almost more like named tuple in that there's names associated with each value. Then you have a stream, which is an unending stream of tuples. Then Storm, we have a spout, which is sort of anything that takes tuples and enters it into sort of the Storm topology, because I'm having to get into what topology means. And so topology, I left one out. A bolt is anything that consumes a tuple from a stream and does something to it, in which case you can then create emit it to another bolt, and so on. And then the topology, which is sort of the overarching concept here, is just the combination of spouts and bolts, by which you can do all of your logic. So another way Storm's been described is like streaming Hadoop. So I guess initially they were doing this in batches. Every hour they would process that day's activity logs, and then that they needed it faster. So then this was the solution they came to, which was to do it in real time. So let's look at what this looks like now. So make this bigger. All right. So just start out with. So okay, back up. The library I'm using to interact with Storm with Python is called StreamParse. It's created by a company called Parsley. They do like content analytics, but Storm is now like a huge part of their infrastructure that powers Parsley's application. So here's the really basic one for just the temperature monitoring. So here I've created like a really simple API endpoint in Flask. So /temperature only accepts post. It gets JSON data, dumps it into a string, turns it into bytes, and then produces it into the raw temperature topic in Kafka. I'm probably talking too fast. Anyone have any questions at this point? No? Okay. So let's look at what the sort of temperature topology looks like. And this is the part we deal with Clojure. You still have to define the topology in Clojure, although I was looking at the issues, and they want a YAML-based thing soon. So soon you'll be only Python and YAML. But so here, oh crap. So we're defining the namespace as temp monitor, and then a function with the same thing. So here's the spout, and this is referencing to a class for this type of spout, and we know that it emits the machine's ID and its temperature. And then here's one bolt where we transform the stream of machine ID and temperature, and we're going to use this class to transform it. And since we're not emitting it, that's the end one. That's why that list is empty. Let's see. So let's see what the temperature spout looks like. It's very simple. So just when we initialize it, we want to instantiate a Kafka client, and then establish what topic we're listening on, and then create a consumer. And then the only other method you have to overwrite for this class is a method called nextTuple. So since self.consumer is the Kafka consumer, we can just sort of treat it as sort of like, it's almost like a generator. You can sort of treat it as an unbounded source of new tuples.
Quick question. I didn't understand, why did you have to use Clojure?
So, so Storm itself is written in Clojure, and so they have like a bunch of clients. Yeah, so I guess for convenience, when they were making this library, at the time, the quickest way to do it was so it's just that tiny amount of Clojure, and the rest is Python. So all this one does is take a message off the Kafka topic and then emit it into the Storm topology. And so the next very simple bolt we're going to have is this one. So same thing, we're going to get a client, get a topic, and then we're going to create a producer. But what this logic does is make sure that if the temperature's changed, we want to put that into a new Kafka topic, which is called temperature change. And then it just puts the new temperature for that machine in it. If the temperature hasn't changed, then we're just gonna not do it and not burden the client side with that extra load. And so the next simple topology we want is just to know how many things we've made in this invented factory. So all that is just a machine ID. There's no other data associated with that message. So this is the spout here. It's going to do a very similar thing as the last one, where it just pulls something off a Kafka topic and then emits it. Here's the machine ID. And then we have this count bolt, which is going to, this is actually a batching one. So normally Storm, you can do like real-time continuously. They also have the option to batch it. So maybe you don't want to see, let's say maybe not, if the temperature ever goes 75 degrees, raise an alert. Maybe instead you want it to be if this has been the average is over 75 degrees for the last 5 minutes, then we need to tell somebody, then it's more forgiving. So you'll just see what that looks like. So again, was that someone? Oh. So it's again, very basic spout. Not a ton going on, but then so now we have a batching bolt instead of a normal bolt, and we're saying that every 5 ticks, and you can configure the relationship between ticks and seconds if you need to. so that it could be 10 seconds or 5 seconds.
So is that what that is?
Yeah.
Is
So
it-
this is just saying how many ticks, and then sort of in the settings for
Okay.
configuring Storm, you can say a tick is 2 seconds or 1 second. So this part's pretty boring, but so since it's a batching bolt, we need to be able to group by. We need a way to group them. So since we know that this is just a bunch of machine IDs, we're going to be grouping by machine ID, which is the first value in the tuple. And then we're going to process the batch, which is the other method you have to do when it's a batching bolt. And so the length of all the tuples, once they've been grouped by machine ID, is equivalent to how many new things have been created in this time period. We're going to update our counter, and we're going to push this new message, which is basically the machine ID and how many it's made at this point in time, into a new Kafka topic, which is just like production count, I think I called it.
You don't care how many tuples are in the batch, right?
Well, yeah, so we care how many there are, but we don't, it can
You
take
don't-
0 or 1,000.
Okay, so
yeah.
you don't.
But yeah, the point is how many tuples are in the batch.
I'm wondering, how is the ordering being enforced? Are all these tuples timestamped, or is there?
So they have something called the offset, so it's not even time-based, and it gets a little bit more complicated than this because you can, since it's meant for a huge scale, you can like partition topics over multiple servers, and I think that, if I'm remembering correctly, within a partition, ordering is guaranteed, and you can actually group it in such a way. So in this case, maybe I could have created a grouping strategy where like the first two machines, even if the topic was split over multiple things, multiple servers, they would only go to one server. So like order could be preserved in that way. Is that?
Yeah, more. Yeah, the fact that it's not timestamped, then there's stuff under the hood.
Yeah, and so I'm not even with Kafka. You can say like, you can actually tell it which point to start from, and then so everything from here as opposed to this. And so actually for this topic, which is just the count topic, I told it to only keep stuff in the topic for 10 seconds because this is happening a lot. We're batching them every 5 seconds. When the user sort of hits the dashboard, they're going to get all the messages that are in that topic sent to the client. So we'd run it to be at most 2, so we're not inundating them. So that's sort of that very simple topology for the temperature and counting it. And then so again, here's the fun part with server sent events. In the beginning, I was thinking I would do this with WebSockets, and when I first made a version of this, I used the Meteor.js framework, and was very unhappy with the performance, and also just it felt wrong to use Meteor. So I wanted to use as much Python as possible. So I created 2 sort of functions here. So one for each of these sort of like processed topics. So this one is just temperature changes for every machine, and it's just going to always send these out. And then this is the other one just for the count. Works very similarly. And now, if you want these to be sent out regularly, you create these new routes that look like this. And this will sort of send data to the client, anyone who's connected regularly. And just the JavaScript, look at this. So my food function. So you create 2 event sources, and then every time there's a message, there's basically a function you hand it to, and this updates the sort of in this each client's global state of the counts and the temperatures for whatever, and then automatically re-renders it.
So you're forcing a reset you're forcing a refresh above opening up a WebSocket. That's a better strategy in general, or?
So it's not refreshing anything. So the server will send it. I don't understand under the hood how this works, but the server will send it the data, and then since this is all React, if you change the global state that this uses to render the view, it then does React magic and then I guess finds the most efficient way to change the DOM's current state to the state it needs to get to, and then alters it.
It's not a WebSocket.
It's not a WebSocket. So WebSockets go both ways. So the client can send stuff to the server with WebSockets, and with server sent events, the server can only send things to the client.
It's like a long pole.
It's like a long pole, but it's not a long pole. So that's like, the ways you could have done this were a long pole or polling, WebSockets, or server sent events. And so like long polling always feels wrong. I don't know, because it's not the right way, and WebSockets seems like such a nice way. But then I was actually Hari at the Sysio who told me about server sent events, and then I went and looked into that. So this is kind of, I had a working version of this. This is when I did the Pytexis. I had a different working version, but then I've been fighting mildew with my car that got flooded on Saturday. So I did not have enough time to get it, complete everything. But this is sort of the basic, this is even dated because that's wrong, the subtitle. But with this data, we could have a dashboard do this, continually updating from a bunch of machines that were probably made 2-3 decades ago. But with this, there's a lot of other options on how we could, if we put more things in the stream. So what if we put, maybe there's a supervisor for every 5 machines that are running, and we have their punch cards. We know when they clock in and clock out. So if we then have some issues we know they happen during that time, we can quickly trace it to that guy. Or what if we also added, very simple camera apparatus to the assembly line after the machine has left the machine? Then we could, do some computer vision stuff, see if this is, try to do automated QA. And we don't have to do any super complicated things. It's just, you could basically design a whole application based off of put things into the stream in order, and then consume them off, and then combine that to come up with something fairly complex, but potentially using really old, dated technology and not having to write that much COBOL or AS400 to make it work. Yeah, I guess I went through that a little quickly, but anybody have any?
This that you're showing, is this a slide or is this actual?
This is not working right now. This is a screenshot.
It's a screenshot.
I had a working one, and I was going to do it with cool charts, but yeah, I ran out of time. But so yes, here's an example at the bottom. I have it logging, but this is sort of is it still running? Yeah. So these are still getting these are server sent events, which is just, in this case, pulling messages off Kafka topic and sending them to the server. Yeah.
For the server sent events, is there a particular library for Flask that you use, or is that part of Flask? Or what do you use for that?
It was nothing fancy. I did some quick Googling and came up with this, right? So I guess you have to get the right MIME type. And
okay, I see.
Yeah, but no, I assumed because when I looked at Flask and Socket.io, you're gonna have to use everybody's saying you have to use Redis, there's some other part to hold it, and I really was glad I could avoid that complexity and just create something pretty simple. Downsides, I think server sent events, I think maybe they still have some problems with IE, but there are polyfills you can do to make it work. The downside with Kafka and Storm is they both use Zookeeper, which I think a lot of people have problems with. I also think in the real world, unless you have a ton of, something massive, you probably don't need to use these tools. But I decided not to wait for an opportunity to try them out and just do them. But I don't know, I think this kind of stuff really excites me. I think.
I have a leading question. Go back to your browser.
Which, this one?
Yes, the one that's, and then can you copy paste that URL into another tab? and then open up the console and see if the stream is still coming through. Okay, and then, what is it?
Yep. Give it a couple seconds.
And then do that 2 more times.
That's for fun.
You don't have to listen to him.
He's very right, you don't have to listen to me.
It's a trap.
Let's break it. Come on. This one's sucking.
So what happens with server-sent events is certain browsers only allow so many open connections at one time.
Okay.
So Chrome itself, I think, is limited to 6.
I
Oh.
think it's any connection. It's
Yes.
long pull request plus
Correct.
service-side event stream plus.
So if you were to try to do AJAX on that 4th tab,
WebSocket.
your AJAX would stall. It would try to do the request and never get a response back.
Yeah, one thing we found is you gotta either you fire hose one stream, right, and you separate them all out based on topic with service and event stream,
Mm-hmm.
or you manage your streams very carefully. Because at some point you have to, switching back and forth between context and the UI, you need to stop a stream, start a stream, depending on what context you're in, or else you'll run out of connection.
Have y'all done any like mixture of like authorization and service and events? Like,
Yeah. They
Build
use
your
the
own-
same resources.
yeah.
How does it know the uniqueness of the context? Is it based on the URL you're at, or?
It's based on open TCP connections.
So
in the specific tab.
Okay, so it's to
Actually,
IP based.
across tabs.
So IP based.
Yeah, I believe it's.
So-
I think it's IP based.
So if you wanted more, you could use a different IP address. Or
Is it
source
maybe
it.
based by the domain?
That's what I'm curious of. How do they know that?
You know,
we
like
have
images are
6
usually
distinct-
limited by domain.
Yeah.
It's either it's
spoof your own IP address.
Right, that's something.
it's
How
either
would you get around
IP
this?
or domain. So
Yeah.
yeah, it
Server
does
A,
it
server B, server C.
across tabs and so you just have to.
So my understanding is Chrome, Safari, and Chrome and Safari allow 6, and I think Opera has a configuration where you can have unlimited, but then you could get banned too by whatever site you're sourcing from. And then Internet Explorer is 2.
I mean, basically, they're trying to control how many open file pointers you have in the system, right? If they let it go to an unlimited, well, then what stops a website from just opening
Right.
tons of file pointers on your system and
You look like you're
crashing?
trying to perform DDS.
So it's just more to protect the user than anything. So I wouldn't recommend disabling a flag and making it. Plus, you can't control that really unless your users are really technical or something.
But
Yeah.
for this application, I mean, he's got a well-defined user base.
Correct.
I think with dashboards, it's like it's probably gonna run on some TV in some room, and no one's gonna touch it, right?
Right.
So that's why, like, another good thing of server events is that no one's really sending anything back to the server because they're just looking at like
Yeah.
Correct.
they're looking to know when they need to say, like, oh crap, like go turn this off. Which they're not going to do via software. It's going to be like with an axe or a switch, like a physical switch.
Breaker, yeah.
It is a very cool technology, though. We like it a lot.
Yeah, I feel like WebSockets like totally overshadowed it because I'd never heard it talked about, and
It is more. I mean,
It's more
under the
work.
hood, it's a little bit more efficient too. You can fire hose one TCP socket and split messages with the subscribers faster than you can do it on WebSocket. So it is much quicker not having to deal with the bidirectional communication.
Is it easy to do this server send event in Django as well, or do you
I would assume so. Let's see.
It looked like it was part of the HTTP headers, right?
Yes. You're literally just specifying your MIME type.
Okay.
And then
That's
sending
all
it.
that's it.
It's-
Well, you're
yeah, it's
sending it in a
text-
specific
it's
format.
text/event stream is what the type. You know.
I did see some stuff for Django when I was looking at this, so I know it's out there.
Okay. Very cool.
So if you make websites, we shouldn't have to refresh anymore.
Refreshing is so bad.
Exactly.
No
So
refresh.
if you have a website, don't make us do that anymore.
Yeah.
You just
What is it?
just-
2013? I mean.
You just have to make sure your payload is correct. That's all with server send
Okay.
events. As long as your payload's formed correctly, then the other side will parse it correctly.
So like in your case, can you pull up the code that has the Flask file that has the views?
Mhm.
So how would you like if you were worried about having too many open connections, how would you combine both of those into one response?
So I was trying to do like intertools.chain to see if that would work, but it didn't.
You need to use if server sent events allows for topics as well. Just
Okay.
like, which is really cool with along with your Kafka and Storm. So they all work together.
They could
very
match. They
well.
could be one-to-one.
So what ends up happening is on the JavaScript end of it, you literally listen for a topic and then you assign a handler to that.
Oh, nice.
So you can assign as many topics as you want to one stream. I don't know how you do that with Flask.
Yeah.
You
So
just-
if you
you
could
just-
show us that, that'd be cool.
You have the little data, the data field, and then you would set event : and then that would give you the, it'd be another line that's event :
Okay.
and that specifies the topic.
We could try it right now.
I think it's
Go
lower,
Dojo.
it's all lowercase.
Live coding.
And
Live
then,
coding.
and then, yeah, your
What
topic
could possibly
is,
go wrong?
Whatever your topic was, you already have topics.
I think you need the space between the colon too. I'm not entirely sure, but
So then on the JavaScript side, where do you specify the?
so you have like a temp source, right?
Yeah.
That temp stream event source. You would do a it's called it's like a temp source dot. Oh, I can't remember.
I know, I'm trying to remember
Top of my
it right
head.
now.
On event listener, I believe. And then you would specify a topic at that point. So let me pull the JavaScript up.
If you just pull up, just look up event source, MDN, they have a really good config, a really good readme. It's nothing, like to understand how it works.
Google's not working.
I'm pulling up our JavaScript right now.
One of the things I do at work is like is working on like a real-time dashboard that takes multiple like very distinct types of data.
Mm-hmm.
Like one's text-based, one's numbers-based, and it's kind of all a mix of things. And so right now we have basically 4 feeds that are more or less long polling. So I'd love to switch over to server-side events, but I feel like we're probably going to add more stuff to it than take stuff away. So being able to combine all that into one is of value.
Yeah.
It's add event listener is what it is.
Add event listener.
Yeah, add event listener, and then the first parameter being the topic, and the second parameter being the callback function. And then
What is it?
there's a third parameter which is for you can just specify false, but it's for cores and things like that. I'm not
He
sure.
doesn't even need it, he doesn't need the second one.
Oh, he needs it.
Does he? I don't think he does.
Yeah, that's how it would work. But this would assume that temp source is like you're fire hosing it under one stream, right?
Yeah, I was actually trying to come up with a way to do that, but I wasn't using.
Yeah, it would be like temp.changed or temp.added or temp.updated. Something like that is what you would end up subscribing to, and then fire off your callbacks that way.
Let's see. I guess the Wi-Fi died because none of my stuff is loading now.
We can do that.
Oops. But yeah, any other questions?
I have a question. So for this PowerPoint and this code, is there like a GitHub or something that's on, or can we get it somehow?
Let me finish getting it working, or make it work again, and then I'll send you else the mailing list. Like, I was literally taking my car interior apart today because I got an inch and a half or foot and a half of water in it, and I'm just scared of mildew. Really don't want that in my 6-month-old car. So,
Oh, man.
but yeah, I'll definitely send out a link afterward.
Awesome.
Yeah, I was really disappointed I didn't have enough time to polish this up, but mildew, it's real bad.
So what's the VIN number on your car so I don't buy it?
I mean, I'll tell you that. Yeah.
All right, yeah, if you don't have any more questions, if you came in late, there's still pizza at the end of the hallway, so feel free to stick around and talk too. So.